Dear students, I am Dr. Rajiv Sapre. This is lecture number 43 about metric topology, and in this lecture actually I will continue the discussion about boundary points. As you know, in previous lecture also we discussed certain things about boundary points. And what is boundary point? It is neither interior point of the set nor exterior point of the set. करेक्ट. म्हणजे तुम्ही असं एक लक्षात घ्या की तुमच्याकडे एक मेट्रिक स्पेस आहे x, d. ओके. आणि a हा त्याचा सबसेट आहे. समजा a इज प्रॉपर सबसेट ऑफ x, a इज सबसेट ऑफ x, वी कॅन से. देन यू नो व्हॉट इज इंटिरियर पॉइंट. करेक्ट. What is interior point? It is a point inside the set A. Interior point always belongs to the set A. Interior point of A belongs to set A. And how it is? See, every point of the set need not be interior point. आपण हे सर्व गेल्या लेक्चरमध्ये किंवा इंटिरियर पॉइंट शिकताना डिस्कस केलेलं आहे. नथिंग न्यू इन दॅट. सो a point x belonging to A, suppose I say a point x belonging to A, when I will say this is interior point, correct? If there exists R greater than 0 such that the open sphere SXR is entirely containing A. So there exists R greater than 0. I am able to find some radius R which is positive obviously, such that if I take center at x and radius r, the open sphere is entirely inside A. Correct? Then it is the interior point. And what is exterior point? It is interior point of A complement. See, so that is obvious. Exterior point is interior point of A complement. So in short, what I can say is that point x belonging to capital X is boundary point of A if x is neither interior point of A okay, nor interior point of A complement. So this is all we have discussed in previous lecture. Neither nor interior point of A complement. So as an example, we can say if I take a usual metric space R, D, and if I take closed interval AB, correct? Then both A and B will be boundary points of that. Why? Because this A is not interior point of closed interval AB, neither B. कारण काय, आपण समजा डायग्राम काढली तर हे समजा तुमचं ए बी असं क्लोज्ड इंटरवल आहे. इफ आय टेक एनी आर ग्रेटर दॅन 0 अँड ड्रॉ open interval around A, it will not be entirely inside closed interval A. Same story for B. So B and A, they are not interior points of the set closed interval AB. Suppose I take this as your capital A. Similarly, if I consider complement of A complement is what? It is minus infinity to A open, okay, union what? Open at B, open at infinity. So this part. But if I take A now, right, then if I draw any open sphere around R, open interval around A with radius R, any radius you take, it will not be entirely inside minus infinity to A, because minus infinity to A contains the points which are less than A, right? And here this part will be some real numbers which are greater than A. आणि त्याच्यामुळे काय होणार बघा की दिस A, similarly the point B, is neither interior point of closed interval AB nor it is interior point of the closed interval AB complement. Closed interval AB we have taken as set A. So this is what? This is actually it is not properly seen. A complement I am writing. So neither A nor B are interior points of A also and not of A complement also. Okay, that is why these 2 points A and B will be boundary points of the closed interval AB. This is what it means. Okay, so this is about boundary points, and I have done lot of examples I have done in previous lecture. So I will not spend time on that now. We will go for some results about interior point and we will try to prove those now. Okay, so I hope you are getting what I am trying to do. Okay. So now some results we will prove, 1 or 2 theorems about this particular issue, boundary points we will try to do. So the theorem says like this. This is a theorem which we will try to prove. So let XD be the metric space, right? Let X comma D be metric space and A be subset of X. Then first part, boundary of A, you know it is denoted by dabba A. It is also same as dabba of X minus A. So boundary of the set A and boundary of the set A complement are same. Very important issue. Okay, we will prove this first. Okay, so how to prove? We know by definition, what is boundary of A? Boundary of A, as you know, it is A bar intersection X minus A bar, right? This is working rule for the calculation of boundary. In last lecture we have discussed that. Okay, so now we will think of so it is what? This is about boundary of A. What will be boundary of X minus A? Same, in place of X you write X minus A. So it will be A bar intersection X minus A bar, but now you will replace A by X minus A. So this will be X minus A bar intersection X minus A bar. Correct? But then what is this? This is X minus A complement, bar intersection. Now X minus X will cancel, minus minus will become plus, so it is A bar, right? But then this is nothing but because this intersection property, you know, these are 2 sets and their intersection is commutative, as you know. So this X minus A bar intersection A bar, you can also write as A bar intersection X minus A bar. So this is very simple, but this is very useful result that we can use. If I want to calculate say boundary of A or if I want to calculate basically boundary of complement of A, then it is nothing but boundary of A. So this result will be very useful. And हा तर working rule आहे. Whenever any set is given, how you will calculate its boundary? Calculate A bar. What is A bar? Closure of A. What is closure of A? You know, closure of A is nothing but A union derived set of A. What is derived set of A? Set of all limit points of A. Set of all limit points of A. Right? This is your A bar. So that is first result. Second result that we will like to prove will be boundary of A is equal to A bar minus A interior. लक्षात घ्या. आता समजा आपण क्लोज्ड इंटरवल AB घेतलं. Okay, this is your suppose set A. What is A bar? If you have a closed set, its closure is itself. So A bar is same as closed interval AB. Then what is A interior? It is open set, open interval AB. And now what you do? A bar minus A interior. It means what? You will subtract these 2 sets, closed interval AB minus open interval AB. So naturally what you get is double turn set A and B. So this is boundary of A bar minus A interior. But then how to prove this? How to prove this? This is verification. This is not the proof. But always you make it a habit that whatever you are going to prove theoretically, verify by concrete examples. That helps you to understand the ideas in better way. This is what I feel, right? So proof we can write. Suppose we have to start with boundary of A. You know it is what? This is our definition, A bar intersection X minus A bar. So we will start with boundary of A is A bar intersection X minus A bar. Okay. So now this is equal to A bar intersection X minus A interior, right? So this is one theorem, X minus A by means using this fact that X minus A bar is nothing but X minus A interior. You can verify this in case of this result also. तुम्ही व्हेरीफाय करू शकता. ओके, म्हणजेच इथे काय होणार ते आता A बार इंटरसेक्शन X मायनस A बार X मायनस A इंटिरियर जे आहे, आपल्याला हा रिझल्ट माहिती आहे की A मायनस B म्हणजेच काय असतं A इंटरसेक्शन B कॉम्प्लिमेंट. सो दॅट रिझल्ट इफ आय यूज A मायनस B A इंटरसेक्शन B कॉम्प्लिमेंट जर मी इथे वापरलं तर X मायनस A इंटिरियर साठी मला हा रिझल्ट वापरता येईल. A मायनस B इन्स्टेड ऑफ दॅट आय हॅव X मायनस A इंटिरियर. मग इथे काय होतं A इंटरसेक्शन B कॉम्प्लिमेंट, तसं इथे काय होईल X इंटरसेक्शन A इंटिरियर कॉम्प्लिमेंट. बरोबर आहे. मग आता इथे इंटरसेक्शन आहे, इथे इंटरसेक्शन आहे. सो असोसिएटिव्ह प्रॉपर्टी जर आपण वापरली तर मला हे काय लिहिता येईल A बार इंटरसेक्शन X, I can club these two things together, intersection A interior complement. But then what is this? A bar intersection X. This will be A bar कारण A bar हा X चा सबसेट आहे. सो जेव्हा A हा B चा सबसेट असतो त्यावेळी A इंटरसेक्शन B म्हणजे Aच असतं. सो दिस इज नथिंग बट A बार इंटरसेक्शन A इंटिरियर कॉम्प्लिमेंट. म्हणजेच काय झालं हे A बार मायनस A interior. See, minus sometimes it is written like this. I should write it same way everywhere. Sorry for this, but this is minus actually. That means this is a subtraction of the two sets. See, this A B A slash backslash B is same as A minus B, and it is means in terms of set intersection union etc. This is A intersection B complement. So this rule we are using this effectively. See, A minus B is A intersection B complement. So I hope you understand this proof. Nothing difficult in that. Only we are playing with set theory. We are playing with set theory and previous results about interior closure of the set and all those things. So I hope you understood these two proofs. They are very simple. Now coming to third part. We'll prove third part now. In third part we have to prove कि boundary A bar is equal to closure of A is nothing but A union boundary of A. Now this is also obvious. If you take, suppose I take what? Open interval AB. Suppose I take capital A as open interval AB which is subset of R. So I am talking about usual metric space R comma D. Then we know that A bar is nothing but closed interval AB. A bar, any open interval when you take, its closure is closed interval. हे आता concretely माहिती पाहिजे. We should know all these things perfectly. Sound knowledge of all these results we must have. मग आता A bar जर closed interval AB असेल तर इथे काय म्हणतोय बघा आपण, A bar is A union boundary of A. What is boundary of open interval AB? You know, boundary of open interval AB is nothing but doubleton set A and B. So we are taking union of A and this doubleton set A and B. Means what? We are taking union of open interval AB, union doubleton set A and B. Naturally, this is nothing but closed interval AB. Right? And closed interval AB is nothing but A bar. So we have proved A bar is A union boundary of A. That is what we have to prove. This is not the proof. Remember, this is just verification. And as I told you, must develop this habit of verifying these results whenever you are proving them, before proving them, or after proving at least. Once you prove the result, you can verify. And then actually you should verify first and then go for the proof. Whenever you are convinced with some some examples, then you can generalize the result. That is the idea behind all these things. Okay, so now what? We will think of A union boundary of A. We will think of this A union boundary of A. Okay, so now as proved in the previous result, this is nothing but A union. Now boundary of A, we have proved in previous result, that is A bar intersection X minus A bar, right? So this is A union boundary of A. So it is A union A bar intersection, intersection it is A bar intersection X minus A bar. Okay. Now what is this? It means it is what? It is A union A bar. You can use distributive property. A union A bar, A union this, intersection A union X minus A bar. But we always know that A is subset of A bar. See, we know as A is subset of A bar. What it means? It implies A union A bar is nothing but A bar. ज्यावेळी एक सेट दुसऱ्याचा सबसेट असतो त्यावेळी युनियन हा मोठा सेट असतो. मोठा सेट यातला ए आणि ए बार मधला ए बार आहे. सो दिस इज नथिंग बट ए बार. ओके, अँड इट्स इंटरसेक्शन विथ व्हॉट? A union. Now what is this? X minus A is a closure, right? Closure of X minus A you can write as A union. It is what? It is X minus A interior. So now what is this? This is A bar. Now this A union X minus A interior. What will be this? A union X minus A interior. X minus A interior. What is X minus A interior? Right? What will be that actually? You are taking C. Suppose this is your metric space. Okay. And this is subset say A. This is your X. This is your A. Right? Now what is A? This is your set. What is A interior? That means we are considering means X minus A interior. A interior म्हणजे हा सर्व भाग झाला. हा आपण सेट घेतलेला आहे ना, त्याचा हा इंटिरियर आहे. हे सर्व बाउंड्रीवरचे पॉइंट्स आहेत. मग X मायनस A इंटिरियर म्हणजेच काय होणार? हे सर्व पॉइंट्स होणार. हे जे सर्व आहेत ते आणि हे बाउंड्रीवरचे पॉइंट्स होणार. त्याचं आणि एचं युनियन म्हणजेच काय झालं शेवटी? इट इज X. It is nothing but X. So I hope you understand that A union X minus A interior is nothing but X. So this is A bar intersection X. We can use this result. We are using this result actually. So A bar intersection X. But A bar is nothing but subset of X. So it is nothing but A bar now. A bar हा X चा सबसेट आहे आणि when one set is subset of other set, intersection is the smaller set. So this is what we have proved. Okay, now the fourth part we will prove. We have to prove now X minus boundary of A. X minus boundary of A is nothing but boundary of A complement. X minus boundary of A, we have to prove boundary of A complement. We will check what we have to prove. X minus boundary of A, fourth part we are proving. So it is A interior, sorry, I want to prove it is equal to it is equal to, we want to prove A interior union x minus A interior. Now this is obvious. We are subtracting from x boundary points of A. Boundary points of A म्हणजेच कोणते, जे neither interior point nor exterior point. They are neither interior point of A nor exterior point of A, म्हणजेच nor interior point of A complement. Okay, so A interior union x minus A interior will be x minus boundary of A. So how to prove this? Okay, so we will start the proof. X minus boundary of A, right? What it means? We are actually calculating boundary of A complement. But what is boundary of A? It is A bar intersection x minus A bar, and so its complement we are doing. So by De Morgan's rules, this will be what? It will be A bar complement union x minus A bar complement. So A intersection B complement is A complement union B complement. That result has been used. Now what is A bar complement? Now I will write it here. I will continue it here. See, A bar complement is nothing but x minus A bar. A bar complement is nothing but x minus A bar union. Now what is that? X minus A bar complement. Okay, so x minus A bar is what? X minus A bar complement we want to find. So it is what? It is, so I can say this is a union x minus A interior complement. We know what we know, that we know that x minus A bar is nothing but x minus A interior and x minus A interior is nothing but x minus A bar. So all these things we can club together. X minus A bar will be x minus A interior and x minus A bracket interior is x minus A bar. So when you club these two things together, what I get? X minus A bar is x minus A interior, x minus A bar, this x minus A whole bar is x minus A interior and x minus A interior is x minus A bar. So when you club these all these things together, what you get is x minus A interior union A interior. Okay, and so this is nothing but, or actually this is what we wanted to prove, A interior union x minus A interior. We can verify these results and it will be very easy to understand. So all these four results that we have proved about boundary of A, they can be used as a characterization of boundary points of A, right? So I hope you understood whatever is explained in this lecture. We will continue with the same concept called boundary points in the next lecture. Thank you.